very common among students. Students might feel they're not very good at math, or any math related question can make them feel very anxious. I was one of those students, by the way, just so you all know. Never good at math. It always used to make me really anxious. And I think with time, I've learned that the way to overcome this kind of math anxiety is adapting a math instruction that encourages curiosity and exploration and a growth mindset. And that is what we will be covering in the next 45 minutes. And I am your moderator for the day. I'll be here in the background to support you. If you have any questions or you're facing any technical difficulties, you can drop a line in the chat box. We will try to keep this as interactive as possible. So any questions, you can use the chat box, comment, use the Q&A box for the questions, sorry, and the chat box for comments, my bad. And then I am very excited and so happy to have DJ West join us today. He's the Vice President of Professional Services. Thank you, DJ, for being here. Such an honor always to be here with you.
Thank you, Sherish.
If you don't mind, DJ, can you just introduce to yourself to our audience, those of us who don't know you?
Yes, my name is DJ West. As you can tell on the screen, I'm the Vice President of Professional Services for McGraw Hill. I actually manage a team of experts. My personal background, I was a middle school and high school math and science teacher for about 25 years, became a principal, and then have been working with McGraw Hill for 16 years in this role, teaching teachers. So it's kind of a fun thing, and I'm ready to explore the topic with you this morning because it's near and dear to my heart.
Excellent. Okay, I will stop sharing my screen at this point.
Okay.
But any questions, just drop them off. And over to you, DJ.
And I'm going to start sharing my screen. And one thing I would like to ask you to do, this is going to be an interactive session. I'm going to do a little bit of the first part. We're going to explore some things that you can do in the classroom to get started. But I want to take you into the topic. And let's go ahead and think about, helps if you start at the beginning, not at the end. There we go. And let's get into this. So the first thing I want to bring up is math anxiety a real thing? And we know the answer to that. And Sherish told a little bit about her story. I just want to tell you really quickly. Growing up in school, for me, math was a game. And I always loved games. And the game was figuring out how to get to the end, because a lot of games that we play at, you know what, you're competing, you want to win, you want to get to the end. And for me, it wasn't competing to get somebody else, but it was competing to see if I could figure it out, you know, like a puzzle or like a Rubik's Cube. And it had that kind of interest for me in doing that. But what we found is that with a lot of students, that's not the mental approach that they take. And in fact, from my personal experience, I have 4 children. Yeah, I know you're thinking you're way too young to have 4 kids, but it's true. I have 4 children. And those 4 children are now all adults. My oldest 3 are girls. And if you went to any of them today and said, "Are you good at math?" all 3 of them would tell you no. And to me, that's a really sad thing, because all of them did exceptionally well all through high school. They went into university. All of them took at least calculus and did well. And in fact, my youngest daughter in high school took AP calculus, got a 4 on the AP test. And yet, if you ask her today, "Are you good at math?" she would tell you no. And the reason behind that is all of them have a little bit of math anxiety, and they have that for a number of reasons. Now, when we say, is it a real thing? I don't just want me to take my word for it. There's been a lot of research that's been done on this. And when you look at that, this is kind of a definition of what math anxiety is. And we all know it's that tension, it's being a little bit afraid of it, it's worrying about the ability to do something. And actually, notice in the second bullet point there, researchers consider math anxiety to be distinct or different from general anxiety or test anxiety, because there are some kids that don't have anxiety in general, but they do have math anxiety. So we want to take a thought about that it is a real thing. And we think about that, what kind of numbers are we talking about? So if you notice here, and this is based on research that's been done in a number of studies, And in fact, one of the things that I'll have in the follow-up pack is a research article that talks about some of the studies that have been done, that if you want to follow up on it, you can. But notice, it's a common issue for many young people and adults, and it's seen in children as young as 5 years old. And I want you to think about that. 5 years old, kindergarten and first grade are already having anxiety about math. And then notice the second bullet. According to Joe Bowler, this was a study done in 2012. Her findings were up to 50% of adults have math anxiety. And then when you accumulate the research that's been done, the average rate among students tends to be about 20%. Now, when you think about 20%, that means 1 out of 5 students in our classroom have that fear, that uneasiness around mathematics. And so that's something we want to look at, because it's a real issue, and say, what are you going to do about it? And then on top of that, I want you to think where we are right now in our educational journey and in our educational society. We're coming back into school for the last year off of what happened in the pandemic. I grew up in Michigan in the States, and I now live in Colorado. I know I'm in Syracuse, New York today, but I live in Colorado now. And in Colorado, you know, we get thunderstorms and we get hail. We don't get tornadoes. But one of the studies that was done by the World Bank actually pulled together 35 different studies from across the world, looking at what happened as a result of the pandemic of COVID-19. And it actually, notice the statement there that goes along with the picture. The pandemic was like a band of tornadoes that swept across the country and the world. Some communities were left relatively untouched, while neighbor schools were devastated. One of the things that we found in the study, that was even within a district or within a school, there's variability in how much that impacted teachers. Now, why do I bring this up in talking about math anxiety? Number one, we know math anxiety is a real thing. Number two, it has been expanded because of the pandemic and the learning loss that happened. Now, when I talk about tornadoes, it's really interesting, because a number of years ago, I was working in Missouri in the United States, and that middle part of our country is really tornado. They call it Tornado Alley. And I was with a colleague, and 2 weeks before, a tornado had touched down, and she took me through the neighborhood where one of the tornadoes had really landed. And what I saw was really unique. We first pulled in, and the first house you go into, everything looks great. The yard's, the yard's fine. Everything's good. Then the next 2 houses are gone. And what happened is the tornado jumped. So it missed the first house, it landed and hit the second 2 and just devastated them. The next house was there, and the one after that, the roof was gone. But that's how it was through this whole neighborhood. It was where it touched down and where it impacted. And that really, on top of what we already have normally with mathematics and the anxiety, has increased this because of that part for the students. And I want you to notice this. This is the reason I have the standard deviation. Simply, this is coming from specific research. I'll actually include this in the folder as well. But notice what happened. On average, students suffered a half year of knowledge and skill loss. Now, in literacy, that loss is still significant. But the way that mathematics builds on itself, that loss becomes even a bigger issue. And then notice the second part. The studies consistently found that the learning loss was also impacted, or the extent of it, by socioeconomic status, past academic learning, the subject of learning. So here's what they found, is that it was more significant in mathematics than it was in literacy. And students that were already behind in math suffered a greater loss than students that were on grade level when the pandemic hit. And I don't think that's any surprise to us. So we know it's real. This chart really just shows the amount of closure in Lincoln schools when students were not in school at all, and then what the learning loss by standard deviation was. Now, I want you to remember, if I come back here, a 0.17 standard deviation loss is equivalent to a half a year. But then if you look down the list, and these are from studies in different countries, how that happened in different places. So like in Switzerland, schools were closed for 8 weeks. There was still a 0.2 learning loss. But if we look at the different countries, we can look at the significance of that for our students. Now, when we think about this, this is really where we're going to spend our time. What causes math anxiety, and then what do we do about it? So there are lots of reasons as you're looking in the research why students have this fear or this unease with math. And if we think about it, I want to throw out 4 different ideas for you. Number one, math, in our classrooms, we have a real focus on being right. And in fact, how good you are at math is often related to how quickly can you be right. So it's not just being right, how quickly can you be right, instead of the focus necessarily being on how math works, because we know all understanding, and especially mathematical understanding, is a process. And what we're doing from 1st grade to 3rd grade to 5th grade to 9th grade to 12th grade is building up that process and understanding so students understand how to do math. And in fact, in mathematics, being wrong is not necessarily a bad thing if we use that to understand how the process works. So one of the things is, we look at that focus on being right, and students are worried about not being right. The second one, a lot of our students have had poor experiences with math. They go to a grade level, they weren't successful. In fact, for a number of years, I used to teach adult ed, students trying to get their high school equivalency degree, so they could go on to community college. And I was teaching the math section. And the first thing I would do, these are students who had struggled with math all through their career. I actually taught them how to find complex square roots. And why did I start with that? Because it was an easy way to be successful. And when they finished that, I was able to say, you've done something that many people with a college degree can't do. And it was about building confidence. So many students have had poor experiences. Number 3, we have a lot of students that have gotten consistent negative feedback. And what do we mean by negative feedback? And you know what? It's a natural thing to do. Well, no, that's not right. That's wrong. Okay. Or we've had parents tell their students, I was not good at math, and we even have some people that talk about the math gene. Everyone has potential in math, but that negative feedback creates then that anxiety. And the last one I'm going to tell you, I think is really important. It's perception from others, where it's kind of being, feeling empathy with others that don't feel with it. And I think one of the things that happens is students have people in their lives that didn't have a good experience with math. In fact, I would say this, I think many of our elementary teachers today are really trained around literacy, and which is so important, but the same emphasis doesn't go into mathematical training. And so often we have teachers in the primary grades that have a little bit of fear of mathematics themselves, and students pick up on that. They feel that. And then, when we're at home and a parent said, well, I wasn't good at math either, so I don't expect you to be. Things like that, they kind of internalize that. And it creates that fear because they're expected to be right, but yet I have this fear that I'm not good at it. And so, there's multiple reasons. It could be a combination of some of these. So there's 2 things I really want to spend the next number of minutes on that are things that we can do. And I want you to think about this. We're wrapping up the school year this year, but thinking about how we could use these even at the end of the year, but then at the beginning of next year to really support our students. So 2 things. One, starting the year off right with our students. And then the second one is using routines to actually create curiosity in students around what they're doing in math. And this one, we're going to spend our time. Now, as we do this, I'm going to go through a lot of ideas really quickly. But the thing I want to do is actually expose you to these ideas. So if you start thinking about mathematics, and I don't care if it's in kindergarten or if it's a senior in high school, these strategies can work with them. Now, I want to start off with starting the year off right. And one of the things we know is that every student does need a good start at the beginning of the year. So there's 2 things that we've done at McGraw Hill. And by the way, you can do this whether you're using a McGraw Hill program whether you're using someone else's in program or you're using no program at all, and you're having to put things together, you can use these ideas. But here are two things that we do at the beginning of the year at every single grade level. One of these, now this is from third grade, one of the things we do is what's called a math attitude survey. And that math attitude survey, if you notice this one from third grade, I can see the math in the world around me. I agree. I'm not sure I disagree. Math is about explaining your thinking, because many students would not agree with that. They think math is about getting the right answer. Notice number 3, and we kind of touched on this, math is about solving equations quickly. Many students would agree with that. The point behind this is so that you know your students' aptitude. And when I say aptitude, I don't mean in a, maybe attitude is a better word that we use right in here, their attitude towards math. Because if you have a student that you know is negative towards math, it allows you then to work with that student in a different way. But this math attitude survey is really simple. When we get up to 6th grade, up into 12th grade, we typically do it kind of at the unit level where, you know what, here's the things we're going to be studying. This is what I've heard of. This is what I know. This is what I don't even remember ever hearing of it. But again, it gives you an idea where the student is in their attitude or their perspective about math. So it's one of the things we start out with, because if you don't know a student's attitude, it doesn't let you approach them in a unique way. And you know what, even if you're teaching high school classes or middle school classes, you have 5 periods a day, it still gives you an advantage working with that student when you know where their mind is around math. The second thing we do, and this is kind of unique, and by the way, again, I'm just going to say this. It wouldn't matter if you're using a McGraw Hill program. We just build this in. You can do this at the beginning of your year with your students. We actually start out with a unit called Math Is. And that Math Is unit is all about setting the stage for how we do math in our classroom and how we're going to focus on it the next year. So we do 6 lessons, not a big long period of time. But I will tell you, it's worth the days that you spend doing this to touch on that attitude for your students. The first thing we do is we start out in a first lesson. It's called Math is Mine. We do this at every grade level in K-5, change it a little bit to 6-12. But what is our math story? And at the very beginning of the year, the teacher gets an opportunity to share their math story with the classroom. What I learned, what I got to do, some of the things I'm good at. And you're going to notice in the picture there, those kids are dressed up in superhero costumes. And in fact, in this lesson, notice it says under Learn, math gives us the power to solve problems. Everyone has math superpowers. You as a teacher get to share yours, and then the students get to think and share their math superpower. Because you know what? Every one of them has something that we consider. In fact, one of my colleagues the other day asked his daughter, who's 9, she said, "What's your math superpower?" She says, "Dad, you know it's adding." And he said, "Why is it adding?" She says, "Because I'm really good at it." Okay. And so she was actually, kind of thrown out that he even asked the question. But this ability for them to share that math is a process and a journey, and how it relates to you, and then how they look at their own math superpower. Okay. In the next 4 lessons, and again, you can still do this without the program, we focus on the 8 mathematical practices or processes, however you use the terminology. And that's how we do math and what math is. Math isn't just about getting the right answer. It's using specific strategies around those. And in the US, in the Common Core Standards, we have 8 specific mathematical practices we focus on, making sense. And you can take a look at those, but those mathematical practices are how we do math. And really what we're trying to do in this Math Is unit is help the students realize that we're focusing on these, because this is what math really is all about. And then in the last lesson, we talk about what is our math community going to look like? How are we going to do math? And in this, at the end of this lesson, students actually get to participate in putting together a listing of what our math practices as a community are going to be, what our norms are, that we listen to each other respectfully, that we work together, that we share our ideas. We actually have a feature called Math is Mindset. When we get up to the upper levels, we keep these same three things. We just alter it in a little bit less formal way. So we just talk about how mindset matters. How do we view challenges as an opportunity? What do we mean by a challenge? When a student gets stuck, I don't know the answer. That's what they're thinking. I'm wrong. I can't do this. Really thinking about it as an opportunity to learn what strategy do I use to move forward. We continue to build in those 8 mathematical practices. Reasoning abstractly and quantitatively is one of those practices. So we look at how that applies in a specific problem and how we use that skill, and we still bring about participating in community with a strong emphasis on mathematical discourse. So the first thing we want to do is really start the year off right. Think about these 2 things and how you could implement those in your classroom. Number 1, a math attitude survey of some type. How do the students feel about math? The big plus to that, it gives you a perception about where those students are. And then the second one, think about starting that year out with something like we just talked about here. Okay, what's our math story? What do we do well in math? Where would we like to grow? How do we think mathematically? What are those practices that really formulate the backbone of math? And then how is our math community going to work? And then the second one I want to walk into is the whole idea of mathematical routines. And this is where I want to bring specifically in this whole idea of curiosity that was in the title of the session. Now, there are multiple different types of mathematical routines. There are sense-making routines, there are mathematical language routines, there are number routines that we build in that are all about fluency. We're going to focus specifically on the sense-making routines. And when you think about routines, and this ties into why it's successful in helping with mathematical anxiety. A routine, by definition, is simply a sequence of actions, but notice the last 2 words, regularly followed. Now, all of us have routines. We all have a morning routine. Think about what yours is. We all have a routine to start off our day, typically. I mean, many of us have a routine about how we eat and when we eat, and some of us have a routine about how we work out. Okay, how we exercise. Routine is just a sequence of actions that we regularly do. Now, these are the 4 different types of mathematical routines. We're going to spend our time on number 1, but I want you to know if this is something you have interest in, take a look at them. The last one on there, there's actually a book from the National Council of Teachers of Mathematics called The 5 Practices for Orchestrating Productive Mathematical Discussions. That's fantastic. But these are the ones that exist, and we're going to spend our time on sense-making routines. Remember, just something we follow regularly. Now, I'm going to start out with this one, and in this one, I would like you to actually put in the chat something you notice or something you wonder. Something you notice or something you wonder. I know I've been talking a long time. I'm going to make you find the chat now. Something you notice, something you wonder. The video is breaking, something I notice. Yeah, I only played it for so long. I don't know if you noticed it, Gene, but actually it stops every so often. And that part is intentional. It's built into the video. Okay, I'm going to wait for one more. And this actually, no, it wasn't. Actually, when it was in it, it wasn't accidental. And you know what, Gene, what it made me think of is when I was looking at that, I was wondering, I wonder if it's stopping to let people off, or if it's something, I mean, that could be, you're wondering if it was broke. The other thing, when you look at this, students can think a lot of things on this. Yep, Annalita, you're exactly right. There are different colors of baskets or different cars that they're writing in. I kind of wonder sometimes when I think about that, if they're different colors because they ran out of paint, they had to paint them differently, if some were put on at a different time, if they intended them to be different. But you know, the thing about this is actually a sense-making routine called Notice and Wonder that is used typically to start off a lesson. We actually call this in Reveal Math our Be Curious moment. We start every lesson off with a sense-making routine. But let me tell you what this does. This allows every single student in your class to notice or wonder something about this, to be able to share that and not to be wrong. It encouraged them to have an opportunity to be able to share their thoughts with what's happening. This one is simply a video that we threw in. You don't need videos. What I want to do is give you some other examples with this. This is a second one. This one is called Which One Doesn't Belong? And I want you to look at these 4 numbers. And if you don't mind, again, in the chat, when you first look at this, which one doesn't belong? And if you don't mind putting in there why it doesn't belong. So again, I'm going to give you a minute. Which one doesn't belong and why? Okay. Jean, excellent. Jean threw in here 5 because it's the only odd number. Okay. Annalita, I hope I'm pronouncing your name correctly. That is exactly the same one that you put in there. Jean, 10's the only one with 2 digits. And in a which one doesn't belong, again, what it is about students looking at an idea and being able to get the reasoning behind it. So in this one, this creates, even among teachers when I use this, it creates a lot of dialogue, and I don't care about the grade level, but students can look at this and say, there's a reason for every one of these not to belong. You know what? 2 is the only number that's less than 5. I could say 2, I could say 8, because 2 times 5 is 10, and 8 doesn't fit in that sequence. You guys already looked. 10 is the only 2-digit number, 5 is the only odd number. But what's interesting is which one students pick, and then from that, their rationale behind why they picked it. But which one doesn't belong is another one of the sense-making routines. But again, the power of it in starting a lesson with this is every single student can have a voice. It relates to their own thinking and background, and they can give voice to the reason behind why they think that is the way it is. Okay. Yep. 2 plus 3 is 5. So we could throw 10 out because of that. Boy, we're getting some real thinking through that. But there's a lot of ways to do that. And what you'll find is the students really enjoy this as well. Now, let's look at a few of these others. Oh, let me back up one. These are the 5 different sense-making routines. There are others, but we're going to look at these 5 real quick. Notice and wonder. How are they the same? How are they different? Which one doesn't belong? Is it always true? And then numberless word problems. Almost all of these can be used at any grade level. I'm going to give you some examples over various grade levels to think, because the idea behind this is for you to start thinking about, how could I introduce this? Because I will tell you what this does. It reduces student anxiety and increases the number of students having dialogue in the mathematical classroom. So we started to touch on it. This is another example of notice and wonder. In this one, we're in 3rd grade. We're starting a unit on fractions, dividing into equal parts. This actual lesson is on equal arrays. But you notice in this one, what do you notice and what do you wonder? So our students looking at this could notice and wonder a lot of things. The things that jump out to me is, okay, I notice all the peaches are in baskets. I think they're peaches. I wonder if every basket has the same amount. I kind of wonder sometimes, are they doing the baskets by the weight or the mass, or are they doing the baskets by the number of peaches? But it gives you the opportunity. I wonder where these came from. So even if a student isn't initially thinking about the idea mathematically, they can think about it in a number of different ways. Yeah, they're arranged in arrays. I don't think that we would have to do that. Yeah, no problem that you have to leave. We're going to send you the rest of the information, Jenny Marie, and share that with you. But this notice and wonder, again, notice the be curious nature behind it. Let's flip ahead. This one is a different type of notice and wonder, so that we're not all calling it notice and wonder every time we use it. It's just a different one called Tell Me Everything You Can. Again, this is coming out of the same 3rd grade unit on fractions. We've just moved beyond arrays. We're getting and looking at how we can divide things into different pieces. And again, just think about this for a minute when you're looking at it. Some students are going to tell me it's an umbrella. I mean, we as a class can start coming up with a list of things that we can tell about this umbrella. We can tell, oh, there are 8 pieces in it. It's got a knob in the middle. There are 4 different colors. The colors are across from each other, but it's starting to get students to think about the idea that we're doing with notice and wonder. Let's move this up into high school geometry, because often when I share these routines, people think they are for primary grades, and that is not the case. This actually starts off, it's Unit 1 in geometry, where we're looking at reflections, transformation, translation. And in this one, students are looking at 3 different parallelograms on a grid. What do you notice and what do you wonder? So if you think about this one, what might students, I'm going to ask you to throw this one in the chat. What might students notice and wonder about this one? I'm going to give you just a second to answer that one. What might students notice and wonder? I'm going to wait on you, just like I would in my classroom. ABCD is enlarged to make HGFE, and that could be. Did they make HGFE by just stretching it out? They all have 4 sides. Notice they're all shaded a different color. They all have a different letter in the center. They all have different letters around the outside. I wonder for M, why A, B, C, and D have little apostrophes up at the top. They're mirror images, or I wonder, are they mirror images? Could I find that out? S and M are the same, or I think they're the same. Are they the same? But you're getting the idea. Even in high school, to start looking at this and thinking about it. The other thing that happens when you do this is students hear the voice of others. Now, I am going to tell you, when I use these, I always like to, you know what, I wonder the same thing. Why is O over there by itself? Okay. But I want to tell you, I normally like to use this with a 3-part strategy that many of you use in other things that you do. And really, it's a think, pair, share. Because I always noticed in my math class, when I ask questions, often, not always, but often, 2, 3, 4 students would raise their hands. And then I would find if I ask a second question, the same 2, 3, 4 students would raise their hand. What happens when we use this in a think, pair, share situation? I'm going to give you a minute to reflect on it, think about it, jot down a couple things you notice and wonder, and don't share them yet. Let everybody get an opportunity to do that. Then what I like to do is break them into groups of 2 or 3. What did you notice? What did you wonder? You guys come up with your list. And then I like to come back whole class, because that's really the opportunity for each student to have their voice, because not all of them are going to say it in front of the classroom. But yeah, when I do that think, I allow them to come up with some ideas, to share it with a partner so they're all having voice, and to do it in whole groups so they're hearing others' ideas. Because some of you might not have thought, I wonder if S and M are mirror images. What does a mirror image mean? But then I start thinking about it as a student and say, oh, I can see that. It looks like it's flipped over that line. Somebody took C and D and just turned it up, pulled it over. That way, I wonder if it would fall and make sense. So notice and wonder can be used at any level with your students. So these are some of the different ways you can say notice and wonder. Tell me everything you can. What questions can you ask? What questions could there be about this? So just different formats of the same thing, but again, students having voice, coming up with a list of different ideas. Now, there's another way to do this in a more extended fashion. This one is called an Ignite activity, and all of you know that there are a lot of rich tasks out there that I can find. This one is kind of unique. Dr. Raj Shah is one of our authors. If you look up his work, he's the co-founder of the Global Math Project. A lot of his work is around student mindset in math and developing curiosity. So in this one, this is an elementary one. It's looking at broken calculators. And this is something we tend to start out a large topic like a unit or a chapter. We start out with an idea because it takes more time than a notice and wonder. In this one, in the Ignite, complete exercise 1, parts A and B with a broken calculator. So your calculator can only add 2s and 5s. how can you make numbers less than 100 with this calculator? And really what it's doing, it's really supporting student number sense. It ties directly to the topic at hand. Notice the second part, your calculator can only add 3s and 7s. What whole numbers less than 12 cannot be made with this calculator? So they're adding, but I can only add those numbers. So what could I come up with out of that? And really it's helping them define number sense in this particular, because that's what they're doing in this chapter that they work with. Let me give you another example. This is a middle school one on ratios. Hector and his sister Luciana made a glass of chocolate milk. Hector mixed a greater amount of cocoa powder in his glass than Luciana did, but Luciana claims her milk has a stronger taste. Notice it's a notice and wonder. What do you notice? What questions can you ask? And so in this, the big thing I want you to note here, students can't come up with a definitive answer. And as they're going into this chapter, this more extended activity becomes an opportunity to reflect back on it during the chapter as we learn more things about ratios to figure out what we would need to know to solve this problem. So in this one, Hector, we know Hector has more milk, Luciana has less. What we don't know, though, is how much chocolate powder went in here, or we don't know the ratio in order to be able to answer this. But again, there's not a right or wrong answer. Every student can participate, and then they can start to learn what are the things that happen that allow me to look at this. Now, this is, as you can tell, a little more extended. It's one of the things that I'll actually put in the folder for you, this along with the teacher answer key that goes along with it, as an idea of something that you could use to really drive that curiosity. So I'll give you the teacher guidance behind it, not only about how to use it, how to build curiosity with it, but then how to strategize and use it with other things. Now, let me give you a second one, not a notice and wonder anymore. This one is, how are they the same? How are they different? Now, this one's fairly obvious when we look at it. We immediately notice they're all round. They all look like they're about the same size. But we also notice they're all cut, in different ways. That's how they're different. All 4 pieces, but all 4 of those pieces are different based on how they're cut up. I actually had somebody ask me one time, we looked at this, if these were pizzas, which pizza would you want a slice of? The one to the far left, the middle one, or the one to the far right? And the answer is, depends on if you like pizza. Because if I want the biggest piece, I'm going to go to the one that's on my far left. Okay. But, if I don't like pizza, then I'm going to go for one with the smallest segment. Or if I want to share equally, then I would do it another way. This is which one doesn't belong. And if you look at this one, what do you think the obvious response would be from your students? I want you to type that in the chat for me. Which do you think would be the obvious choice for your students? The one that doesn't belong, I think I agree. 6 times 8 is the obvious one because all of the others are double numbers, but 6 times 8 is not. But you could have some students that would look at this and say, I think 7 and 7. That's right, exactly, because that's going to give you an odd number. Yep. And so I want you to think about when you look at this, but again, it's just a curiosity. Even though one comes out more, you can actually see the reasoning of other students in thinking about how that number takes place. I could pick 4 by 4 and say it's the only one less than 40 because all the others are going to be bigger than that. I could take 10 times 10 because it's going to be the only 3-digit number that comes out of it. Lots of ways you could do it, but which one doesn't belong? Let me run just through a few of the others for you. This is another which one doesn't belong. We're getting into algebra, looking at functions. And if you think about that, what a great way to look at this by students. I know a lot of my students would automatically choose D because they see the fraction in it, but I would have a lot of other students that would choose C because in C, the n is not an exponent. So think about it, again, just a way to start out the lesson to do that. This is called a numberless word problem. Some apples, and this, we see it more in the primary levels, but some apples are on a tree. A horse eats some apples are left on a tree. And so what we might do is have students actually draw this. And when they draw it, it really becomes interesting. We're looking at a first grade problem on subtraction. But I will tell you, if a student could draw this, the number sense that that creates is fantastic. And again, it takes away some of that anxiety that students have when they're thinking mathematically. This is one of those types called "Why is this true?" This again is a high school problem. Look at the two circles with centers A and B. Based on the diagram, how do you know each statement is true? So here they're having to give reasoning based on it. And I've got a number of different statements below that they have to use the diagram to identify that. This one is simply called a math talk or a number talk. Solve each equation mentally, 40 minus 8, 40 plus n. Okay, and in this problem, students get the opportunity to work through it, but they get to express themselves again. All of these kind of take away that anxiety. So, you know, nothing, I would say this, nothing profound today, but really, what are the two things that we can do to really help students in our classrooms with this idea of math anxiety? There are others. This is not in any way comprehensive, but if I want you to think about it, number one, starting the year off right, looking at that attitude survey so that you as an instructor know where your students are in their attitude about math and their perception of what math is. Really important. And then I would challenge you to think about as you start next year to incorporate some of that. You know, what is your math story? What's their math story? Even using the idea of what's their math superpower? What do they do really well in math? Because, you know, all of them do things really well in math. Secondly, spending some time at the beginning of the year thinking about what math is and how we do math through those mathematical practices. And then number three, setting up a set of norms for us that, you know what? Math is about the routine or the process that we do to solve problems and learning that process. And in learning any new process, we don't always get everything right. And then setting up what those classroom norms are for your class. And then the second one, thinking about using some of what we call these mathematical sense-making routines to start your lessons off to give every student an opportunity to have voice and express themselves without a fear of being wrong. You know, really one of the biggest things we have to remove is the fact that math is all about how fast can you get the right answer. Math is about learning and understanding the process so that we can significantly use the math in new situations. Because if I only use how to get the number correctly, it doesn't mean I know the process behind it. And then when I transfer it, I may not be successful in doing that. So with that, I want to stop because we're right at time. And then what I'd like to do, just any other questions you want to put in the chat in the Q&A, be glad to do that. I'm going to share some resources with Cherish to send out to you along with the recording for the session. If anyone has any questions or comments or thoughts, just throw them in the chat or in the Q&A.
Thank you, DJ. That was a great
I was just going to say, Cherish, if you have any housekeeping to share, please do that.
Thank you. I just want to thank you. It was very interesting. Thanks a lot. And if anyone has any questions, we can take them up right now. I'm going to drop my email address in case you have any question later on, or if you want to inquire about anything. We're happy to support you. So I'm just going to drop my email address in the chat box. If you've got any questions, you can note that down. It's marketing.mia, MEA @mheducation.com, marketing.mia@mheducation.com. Thank you so much, everyone, for joining us today. It was great having you here, and I hope to see you next time. Okay, I see a question. What would you do with the culture around us? One where knowing Justin Bieber is required, but knowing math is actually looked down upon.
You know what? the biggest thing with that one is this. I think the other thing that some of these types of strategies do is they show the application of math in the real world. And what I mean by that, Gene, is this. A lot of our kids, I think even my daughters, one of the reasons they had that math anxiety, or they would say they're not good at math, that kind of thing. While we were doing math in the classroom, they didn't really ever see the application of the math in a setting. So one of the things that we've tried to do at McGraw Hill is every time we start a new topic, and we call them modules in the program, every time we start one, we actually started out with a real world video that has several applications of the math. Like, for example, one of the ones we do when we're talking about slope, it starts out with a plane taking off and what it needs to do to get up and the angle it goes at. But the second one, I think, really relates to our students. It looks at the strength of the internet signal, depending on where the router is in the house, and looking at how we use that to create slope and use it to understand what we have to do to increase that. Every one of the students, when I bring that up, is immediately interested, because all of us have had that experience where we're moving around trying to get that signal. But I think the more that we can create it to what's happening and its actual application, the more we can remove that stigma of it being looked on. The other thing I think that I would do in that, one of the things that we know across the world is that the greatest potential for career opportunity in the future is in STEM. I mean, in our society today, that's where so many of the jobs are coming from. And I don't care if it's science-oriented, technology-oriented, the background behind that is the mathematical framework that supports that. But again, it's a real-world aspect to what we're doing with math. And I think the more we can build that in. The other thing I think the sense-making routines do, a lot of our students think of math as an opportunity. I come in, what problems did you struggle with? Okay, let's work a couple of those here. Let me introduce a new topic. Let me show a couple examples. Let me, then you practice some problems. And really what happens, it's very much a single spectator sport rather than a collaborative effort. And the more we can get students interacting with one another, I think that then is what also creates some of that interest from students that hadn't had it before, because they're able to talk with each other about it. Oh, you know what? That you're true. There are going to be some students. And so really what we're doing is trying to create the dynamic for the whole class. You're always going to have individual students that want to play a game. You're right. I mean, whether they're playing in a literal game or whether they're playing the game to get the grade because that's all I want to do, we're going to have that. But I think the more that we can build that into the culture of our classroom, the more we'll see more and more students actually coming around. And I think that's where rich tasks and these routines come into play in helping our students develop a more positive attitude about math. Great. And by the way, great observation, because you're absolutely right.
Thank you, DJ. And I guess that brings us to the end of the webinar. If anyone has any other question, thank you once more.
Yep. Guys, have a great evening, whatever
Yes.
time zone you're in, and hopefully we'll have an opportunity to interact again.
Yes. Thank you so much, everyone. Bye.